Hello everyone, this is Deepak Joshi, and today we are going to solve another problem statement from GFG, Geeks for Geeks, that is top view of a binary tree. Previously, like the last video that we saw, that I shared, contained the explanation for the bottom view of a binary tree. This problem is the top view of binary tree, and which is exactly same compared to that particular problem. Let's discuss that problem first. That problem was bottom view of a binary tree. What does that mean? That mean if I try to see or watch a binary tree from the bottom, then what are all the nodes that I'll be able to see? So in that question, what approach that we followed is we followed that we should consider the whole binary tree in y-axis, and then we just try to look up to the nodes that are like on the y-axis. Okay, I can explain it better. Let's say we have 1, 2, and 3. If I'll try to figure out the bottom view of this particular binary tree, then what I'll do is I'll place this binary tree into y-axis, where my root node will be my origin frame of reference. Okay, so here like one will be zero, like zeroth position, and anything which is on the left side of the one, that will be minus one. Okay, and anything on the right side of the root node, that will be plus one. So the position of one will be zero, and two will be minus one, and three will be plus one. Okay, let's talk about this as well. So 10 is on 0, 20 is on minus 1, 60 is again on 0. Okay, that is the main trick. So if 60 is on 0, in that bottom view case, we will overwriting 10 to 0, like 0 on 0th index 10 is present, but we were overwriting it to as 0th index 60 is present, because that was the bottom view. Okay, and 40 will be on minus 2. Okay, minus 2th index will be covered by 40. Similarly, 90 is also on 0th index, because 30 is on plus 1, but then on the left side of 30, that is plus 1 minus 1. That comes out to be 0. 0th index was occupied by 60, but we were overwriting it to 90. That's why 90 was the answer in that case. And 100th position was like 100 is at position plus 2, because root nodes right plus 1 30 plus 200. That makes complete sense for the bottom view. Okay, but here the question is related to the top view. We need to consider only one thing, that we do not need to override the things. That means if I try to watch, like see the whole binary tree from the top, then in that case, I just want to make sure that no overwriting happens. That means zeroth index is covered by 10, for plus 1 index is covered by 30, plus 2 index is covered by 100, minus 1 is 20, and minus 2 index is covered by 40. That's it. No overwriting happens over here. How we are going to do this? BFS or BFS, Deepak? Any approach will work over here. No, not any approach will work. Because let's say why any approach will not work here in this case. Let's say the graph starts from 10, we are tracing DFS 10, 20, 60, 30, like 60 or 75, 10, 20, 60, and 75. In that case, 75 will be plus 1, but according to us, the plus 1 should be 30 if there is a right hand from 10 as well. So again, BFS is the only choice that we need to do level wise traversal, so that we consider the top nodes first, or we consider it level wise, so that if we are considering any below node, we are sure that we have traced all the nodes that are present on top of it, or the siblings of the parent nodes has been covered. That is our approach. Let's try to code it over here. Like we need to return an answer. I'm just picking up an answer over here. Now to perform BFS, what we need is we need a queue, and in that queue we will be storing a pair that will contain nodes. Okay, tree nodes, and we will require the index of it. Let's name it as q. It will contain node and the index. That makes complete sense. We need a map that will be int comma int. What will this map contain? This map will contain the index and the node value that we need. For sure we need this thing. And now let's just push the root node with the index 0 over here. Now let's start tracing the map q dot until it is empty. Okay, that makes sense. What we will do is we will fetch out the front node of the queue. That will be auto it is equals to q dot front. And what we need from it, We need the front node. I am just writing front. You can write front node as well. That will be it dot first, and we need the index that we are planning to store. That will be it dot second. For for the guys who thinks that it is very fast, just try to watch the first video. You will like everything will make sense to you. Index equals to it dot second. That is what we need to do, and now we will be popping everything up. Here the condition change. Previously what we were doing is we were just doing a map of index equals to uh, fronts data. Now but we can't do this right now. We need to check one thing, that map dot, there is one function that I need to take care of, that is over here. Not sure count works. Count works, yeah, count works. Contains was not okay. Let's make sure that map dot counts is for the index, and it should be equal to less than equal to 0 if that is the case. And yeah, that makes sense. Only update when we have not traced this particular index. If we have the traces for this index, just skip this part. Like if I haven't traced 10, means zeroth index, consider 10, minus 1 index, consider 20, minus 2, 40. If I am again on 0 and it is suggesting 16, do not consider this. That's it. Now I'll what I'll just do is I'll check if its left exists. That means if it is not equal to null. If that is the case, push fronts left along with the index, and left should be index minus one. And I'm just putting an extra space over here. If fronts right is not equal to null, what I'll just do, I'll do q dot push front, front right comma index plus one. Okay, that makes complete sense over here. And once we will finish this while loop, what our map will have the nodes with along with the indexes, and I just need to push all of the nodes to my answer. That will be it dot, because we have stored it in second. So that's it, and I'm just returning my answer. This should work, and let's see if there is an error. If there is a syntax error, mostly. Oh, it says yes. It says q pair node index. Node was not declared. Okay, I know node is not declared. Another error. Same line, that makes sense. Complete. It says counts has no member name counts. Okay, and I was doing count. It is count. I'm so sorry, guys. Just please have it as count. Count. Submit. It should work. It worked. Okay. Yeah, this was it. Let me go through it once more for you. So what we were trying to find out is we were trying to find out the top view of this particular graph. What approach took? We took the BFS approach along with not considering the already existing indexes. We just hopped everything into a y-axis scale, and then we started with root node having frame of reference, which is 0, and then we iterated over the nodes according to the BFS, and we only updated the index if that is not being updated. Like it is the first time we are getting that particular index, and then we just stored everything in our answer and returned. See you guys in some other video. If you have any questions, any doubt, please feel free to reach out. Thank you. Bye bye. Take care.